At the foundation of our existence lies a realm governed by rules so bizarre they defy human logic, the quantum world. While classical physics explains the motion of planets and falling apples, it fails completely at the subatomic level. Here, particles behave like waves, existing in a ghostly haze of probability rather than fixed locations, challenging our very perception of what it means for something to be real. The gateway to this strange dimension is the famous double-slit experiment. When scientists fire individual electrons at a screen with two slits, the particles produce an interference pattern as if they were waves passing through both slits simultaneously. However, the moment we introduce a detector to observe which slit the electron passes through, the wave function collapses, and the electron acts like a standard marble. This phenomenon, known as the observer effect, suggests that the act of measurement itself forces the universe to choose a single outcome. It implies that at a fundamental level, reality is not a static stage waiting for us to enter, but an interactive process. The universe remains a sea of infinite possibilities until a conscious observer, or even a measuring device, forces it into a definite state. Even more unsettling is the concept of quantum entanglement, which Albert Einstein famously dismissed as spooky action at a distance. When two particles become entangled, their states remain perfectly correlated, regardless of how much distance lies between them. Change the spin of one, and its partner instantly reacts, appearing to communicate faster than the speed of light, violating our conventional understanding of space. This connectivity suggests that our universe might be non-local, meaning that the fabric of space-time is not as rigid as we once believed. If two particles separated by galaxies can remain linked, it hints that the distance we perceive in our daily lives might be an emergent property, a simplified interface masking a deeper, hyper-connected reality that we are only beginning to comprehend. Theoretical physicists are now exploring the holographic principle, which posits that the entirety of our three-dimensional universe could be encoded on a two-dimensional surface at its boundary. Much like a 3D hologram projected from a flat plastic sheet, our perceived reality might be a projection of information-dense data existing on the edge of the cosmos. As we bridge the gap between quantum mechanics and general relativity, we move closer to a theory of everything. This pursuit isn't just academic, it forces us to confront the possibility that the objective world is a construct of our consciousness. We are not merely inhabitants of the universe, but participants who shape the narrative of time and matter through our interactions with the quantum field. Ultimately, the quantum journey reveals that the solid world is a beautiful, fleeting mirage built on the shifting sands of probability. We stand at the precipice of a new scientific era, where the boundaries between observer and observed dissolve, leaving us with a profound realization: the universe is not just stranger than we imagine. It is stranger than we are currently capable of imagining.